Hi, welcome to my video on the limits to infinity, number 3. Find each limit. So in this video, we'll look at when the numerator has a higher degree than the denominator. So this one, the degree is 2. This one, the degree is 1. So we got a quadratic being divided by a linear. So what we do here is that we take the limit and we divide the expression by the degree, highest degree of the denominator. So it's x squared divided by x, and it's x divided by x plus 1 divided by x. So that's the limit as x goes to infinity, and x squared divided by x is x. X divided by x is 1 plus 1 over x. So as x goes to infinity, we get infinity, and as x goes to infinity, and the constant is a 1, and 1 over x as x goes to infinity becomes 0. So that gives us infinity over 1, which is infinity. Now, let me explain more about this one. So, because the numerator has a degree of 2 higher than the degree of the denominator, we have what we call a vertical asymptote. So we have a vertical asymptote at x equals negative 1. So the vertical asymptote is x equals negative 1. So we have a graph. We have x equals negative 1. So let's say this is negative 2, negative 1. So vertical asymptote is right here. So this is x equals negative 1. But we also, because we can divide, x plus 1 can divide into x squared. Because the numerator has a higher degree, we'll have a horizontal asymptote here. So if we divide x plus 1 into x squared, x into x squared goes, so this is a 0x, and the constant is 0. So x squared, x divided into x squared is x. Multiply back, we get x squared plus x. Subtract, that becomes a negative, and this becomes a negative. So they cancel out. So 0 minus 1 is negative x. Bring down to 0. X into negative x is negative 1. So that get negative 1 times x is negative x. Negative 1 times positive 1 is negative 1. Subtract, that becomes a plus. So that cancels, that becomes a plus. So that gives us 1. So when we divide this expression, we get x minus 1, and the remainder is 1 over the divisor of x plus 1. So this limit, the limit of as x goes to infinity on this function, so instead of writing it as x squared divided by x plus 1, we write it as this binomial and this fraction. So when you let this go to infinity, 1 over x plus 1, this is going to infinity. So 1 over infinity gives you 0. So you get x minus 1. So the oblique asymptote is y equals x minus 1. So we got a vertical asymptote at negative 1. We got an oblique asymptote going up through. So that means y-intercept is negative 1. Let's say is right there. Let's say that's negative 2. And the slope is 1 over 1. So we rise 1, run 1. Rise 1, run 1. And so the y-intercept is negative 1. And it's an oblique asymptote going sideways. So there it is there. So this is y equals x minus 1 oblique. So that means that this rational expression fits in here somewhere. So what we do, we can take a value of 0. Remember, it goes towards the asymptote. Either it goes up here or it goes up here. And if it's down here, it goes down here like this, or it comes in here like this. So let's take a 0 and put a 0 in. So when x equals 0, we put a 0 in. We get 0 squared, 0 over 0 plus 1. We get 0 over 1. So when x is 0, y is 0. So that means, so when x is 0, y is 0 into this expression. So that passes through the point 0, 0, which is here. So that means that it goes along by this asymptote and comes like this. So this is an asymptote. This is an asymptote because the point is in here. It goes, as x goes to a negative 1 on the right side, it goes to infinity. As x goes to infinity, y is going to infinity, which is what we're doing here. Now, the other part of this one is right here, where x goes to negative infinity. So if x is going to negative infinity here, where is this graph? Well, let's look at x is negative 2. So let's look at x is negative 2 into this expression. So what we have is, we have negative 2 squared all over negative 2 plus 1. So that's 4 over negative 1. So we get negative 4. So we get negative 2 gives us a negative 4. So we're looking at the same expression, x squared all over x plus 1. There it is there, but at this time it's going to negative infinity. So it passes through the point of negative 2, 4. X is negative 2, y is negative 4. So that stays right there. So again, as it goes, as we approach on the left side of negative 1, it's going to go down right here like this. So as this goes down, so this function goes along by that vertical asymptote and along by the horizontal asymptote. So to answer this question, as x goes to negative infinity this way, y is going down towards negative infinity. Oop, put negative infinity correctly. But let's work that out. Because I had the graph drawn, then if I didn't have the graph drawn, let's put divide by x squared divided by x, and x. So I divide the numerator by x, the denominator by x. So that's the limit of x going to negative infinity. Let's simplify this. That gives us x. 1 plus 1 over x. It's exactly the same as what we have here, but this time we're going to negative infinity. As x goes to negative infinity on the 1, we get a 1. As x goes to negative infinity of 1 over x, that goes to 0. So that gives us negative infinity over 1, which is negative infinity. So doing it this way, filling it in, we get negative infinity. But what I did here, I graphed the horizontal asymptote, or sorry, the vertical asymptote, the oblique asymptote, and you see that the graphs fit in here. So I did the graph to explain, even though this is the way I would do it algebraically, without doing the horizontal, without doing the vertical asymptotes and the oblique asymptotes. If you did this and come up with infinity, that will give you the marks. You're correct. But I put the graph in there to explain it also. Okay, let's continue. What about, we have x squared, which is a parabola on top, and a linear on the bottom, but this time we got a negative. So let's take the limit, going to infinity, and we'll divide the numerator by x. Okay. Notice this is x squared, this is x, so I'll divide by x. It's because the numerator power is larger than the top one, we will divide by x. So we got limit as x approaches infinity of negative x plus 2 minus 5 over x, 1 minus 3 over x. So as we go to infinity, we get negative infinity, constant, 0, and we get 1, as a constant, which is 1, and as a 0. So that gives us a negative infinity plus 2 over 1, which is negative infinity plus 2, which is negative infinity. Oh, negative infinity, simple. So the limit here is a negative infinity. And I did it by dividing again the top and the bottom by x. And another one to do is, what about if we have another one, but this time we're going to negative infinity. Again, the numerator power is larger than the denominator power. So we'll divide by x. So 8x squared divided by x plus 1 divided by x, 2x divided by x plus 2 divided by x. So let's simplify that. X. So we have 8x squared divided by x is 8x. 1 over x. 2x divided by x is 2. And we have 2 over x, can't simplify. So as we go to infinity, we have, this is going to, negative infinity, so it's 8 negative infinity. 1 over x going to negative infinity goes to 0. That's a constant, which is 2. 2 over x going to infinity becomes 0. So that gives us negative 8 infinity all over 2. Negative 4 times infinity. So that's, if you got infinity, 4 times is still infinity, so it's a negative infinity. Again, because this is the right answer here, working it out algebraically, but if we want to take it one step further and explain it, just again, I'd like to explain that if we have this function, and let's divide the function out, so 2x plus 2 divided into 8x squared plus 1. So let's put the plus 1 here with a 0x in the middle, because we have to go down descending order of 2, 1. That's x to the 0 here. That's a constant. So we divide by 2x, we get 4x. Multiply back, we get 8x squared plus 8x. And we're subtracting, so we make the plus a minus. We make the plus a minus. So it cancels out. That gives us negative 8x plus 1. 2x into negative 8x is negative 4. Multiply back, negative 8x minus 8. We're subtracting, so we take the negative and make it a positive. We take the negative and make it a positive, so they cancel out. So that gives us a 9. So that gives us 4x minus 4 over 9 all over 2x plus 2. So this limit, if you think about it, this is the limit as x approaches negative infinity. So this expression here becomes 4x minus 4 and 9 over 2x plus 2. So that means that this is the horizontal asymptote, the oblique asymptote. We got to be careful. Again, because this power is larger than this power, we have an oblique asymptote. And the oblique asymptote is y equals 4x minus 4. So that's, if we want to take it as a minus 4 right here. So that's a minus 4, up 4, right 1. So this is the oblique asymptote going through here. That's y equals 4x minus 4. And notice also we have 2x plus 2 is equal to 0. 2x equals negative 2. X divided by 2, we get negative 1. So the vertical asymptote is that x equals negative 1. So that's, again, down through here, like this. So again, where is this function? we have it's going to negative infinity, but okay. So if we put a 0 into here, we put a 0 in here, we get 0. That gives us a 1. Put a 0 here, we get a 2. So at 0, we have a half. So that's a wonder. A half is right here. So that means it's doing this and this. And if we put in negative 2 in here, we'll get a number down here. You can sub that in. And also another point of, well, we can put negative 2 in. So x, let's do it anyways. Put a negative 2 in. 8, negative 2 squared plus 1. And 2 times negative 2 plus 2. That's 4. 32, that's 33. And that's negative 4 plus 2 is negative 2. So that's a negative 16 and a half. So it's way, way down here. So when x is negative 2, we get a negative, again, you can see it's down here. Negative 2 is way, way down here. But an interesting point that I want to look at is your horizontal asymptote, your oblique asymptote, y equals 4x minus 4. Your vertical asymptote is x equals, we're going to do that right here, negative 1. So if we take x equals negative 1 and sub it in, we get negative 4 minus 4. Y is negative 8. So x is negative 1, y is negative 8. That's the point of intersection of your vertical asymptote and your oblique asymptote. So this point here is x is negative 1, y is negative 8. This is where the two asymptotes intersect. So the graph is, again, intersecting here going towards this asymptote, oblique going towards this asymptote, which is vertical. So it goes through this point, it's going towards this asymptote, which is oblique, this asymptote, which is vertical. So we said, as x goes to negative infinity, again, you see y is going to negative infinity, which is what we did algebraically, but I'm explaining it all here, because when it's explained out, it makes more sense. And again, if you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained, with just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye. Oh, a little bit crooked there.